Newton's first law. An object in motion will remain in motion unless acted upon by an external force, and an object at rest will remain at rest in the absence of other forces. As you could see, the object continued moving until it was acted upon by an external force, the book in its way. Having had a force applied to it, the object will move at a constant speed forever unless acted upon by an external force. The book being in its way, the object hits against it, receiving a force equal to the force it exerts against the book, stopping its forward motion. As is apparent from the video, the object remained at rest until acted upon by an external force, in this case my hand. Newton's second law dictates that the acceleration of an object is dependent upon the force exerted on the object and the mass of the object. The greater the force, the greater the acceleration, and the greater the mass, the lesser the acceleration. Despite both video clips involving the same object, in the first video clip it receives a lesser applied force than in the second, and, as is apparent, it receives a lesser acceleration than in the second. After applying approximately the same force to two objects of differing masses, the one with the greater mass received a lesser acceleration, and the one with the lesser mass received a greater acceleration, in accordance with Newton's second law. Newton's third law. For every action there is an equal and opposite reaction. Having applied approximately the same force to both barbells of equal mass, when they hit each other, they receive the same acceleration and force in opposite directions. Despite receiving identical applied forces, the objects do not experience the same acceleration upon hitting. Instead, the larger object receives a smaller acceleration, and the smaller object a larger acceleration, with those accelerations being in opposite directions. This concludes my presentation. Thank you for suffering through it, without laughing, hopefully.